Hi everyone, in this video we will see the operation of single phase to single phase, a step down cycloconverter bridge type configuration. The bridge type configuration converts AC input at one frequency to an AC output at lower frequency. So this type of converter is more complex than the center taplet type, but offers a better performance in terms of harmonic reduction and power handling. So this is a bridge type circuit. The circuit consists of two group of thyristors, positive group and negative group. The positive group thyristors are P1, P2, P3, P4. Negative group thyristors are N1, N2, N3 and N4. If you look at the operation, during positive off cycle, during first positive off cycle of the supply voltage, the B is made positive with respect to C. Now if you look at the thyristor, the P1 and P2 connects, right? So once you give a gate pulse or gate current to the thyristor P1 and P2, then the P1 P2 starts conduct and it carries a current like this through P1 load, P2, then it comes out through a C terminal, right? Current is going through B, P1 load, P2 and comes out through C terminal. So if you look at the load voltage and load current, the load voltage, load current are in this positive direction only. So from 0 to pi during positive off cycle, the thyristor P1, P2 starts conduct and the output voltage and output current are in the positive direction only, right? So it just follows the same envelope of the supply voltage after the firing angle alpha. Now, if you look at the negative cycle, so before the negative cycle at pi, the P1 and P2 are naturally commutated, right? So because the output voltages reaches to 0, so the thyristor P1 and P2 are completely turned off, right? So after a firing angle of alpha, we are going to give a gate pulse to thyristor P3 and P4 during negative off cycle. So during negative off cycle, what we are going to do? We are going to make B is negative and C is positive, right? So if you look at the current flows through P3 and P4. So the P3 and P4 now conducts after giving the gate pulse. Now the current is flowing through B3 like this, P3 load, P4 and comes out like this, right? So it starts from C, then goes to P3 output load and P4, then it comes out through B, alright. So what happens is the output voltage and output current are in the same direction. From pi to 2 pi, the cycle is negative. But once this here P3, P4 starts conduct, the output voltage and output current in the same direction. So which means it is a positive direction only. So the output voltage and output current just follows the supply envelope, right? So the positive direction, right? Now again I am going to give gate pulse to thyristor P1 and P2. Again we will be getting one more cycle like this, right? Now on the negative side, if you see the negative group of thyristor, I am going to give B is positive and C is negative after the value of 3 pi. Okay, after the value of 3 pi, I am going to give gate pulse to thyristor N3 and N4. Okay, so N3 and N4 gate pulse is given, and you can see that the voltage and current, this is going in the opposite direction, right? So through N3, the load current like this, then N4. Okay, so the load current is in the opposite direction. If you look at the output voltage and output current is in the negative direction, right? So after it reaches 4 pi, again we are going to give a gate pulse to thyristor N1 and N2 to conduct, right? So N1 and N2 is conducting and the N3 and N4 are naturally commutated at 4 pi, right? So N1 and N2 conducts. Again this will get the negative voltage and negative current, which means the voltage and current are going in the opposite direction only, right? So we'll be getting the negative off cycle. So the thyristor N1 and N2 conducts, the output voltage, output current are in the negative direction. Again I am going to make N3 and N4 to conduct, so you'll be getting one more cycle, right? So if you look at the waveform, the output frequency is equal to 1/3 of the supply frequency. So if you give the gate pulse In this particular manner, we can able to get the output frequency is equal to 1 by third of the supply frequency. So the bridge type of circuit offers a better harmonic performance compared to simple configuration like a Saturday type. And if you look at the power handling, it is suitable for high power applications due to the use of multiple thyristors, and also it offers a flexibility in controlling both positive and negative off cycles independently. The bridge type cycloconverter are used in various applications whenever we have a precise motor speed control or different power grids with varying frequency or high power machineries requires a variable frequency input. For these applications, we can use a bridge type cycloconverter circuit.